one sunny day.
Good morning, class. Bring out your assignments, number 1 on the board.
Don't call me. Please don't say my name. Please don't say my name.
Ma'am, I volunteer.
I know the answer, Miss Reyes.
Other hands, please. Let's give others a chance to answer.
What about RB?
Oh no.
You can do this!
Actually, recess! Whew, saved by the bell.
Hey!
Hey!
Can you please stop bothering me? Guys, I'm so devastated right now. Please don't talk to me. I'm really embarrassed.
But why?
I can solve math problems. What if I'm not smart enough to do math?
What? That's not true.
Oh no, don't think about it like that. We can exercise your brain in math.
By challenging it.
Good day, gals and guys! So for today, we are going to learn how to solve a problem relating to both ellipse and hyperbola. But first, you must know how to differentiate these two conic sections and its definitions.
Let's tackle first the ellipse.
An ellipse is a plane curve surrounding two focal points, such that for all points on the curve, the sum of the two distances to the focal points is a constant. It generalizes a circle, which is the special type of ellipse in which the two focal points are the same.
While a hyperbola is a set of points in a plane whose distances from two fixed points, called its foci, have a difference that is constant.
Now, let's take a look at our given problem. Here, we are looking for the standard form of equation of an ellipse whose minor and major axes are the transverse and conjugate axes of the given hyperbola.
We're given a general form of the equation of a hyperbola, which is 4x squared minus y squared plus 64x minus 2y plus 111 equals 0.
So firstly, we must convert it into a standard form. In converting the equation, we need to rearrange the equation first and factor out the leading coefficients.
Next is to complete the squares, and following the addition property of equality, we must add the values we added to the other side of the equation. So we got 144. We need to divide the whole equation by 144 to have a value of 1 on the right side. Finally, we got the standard form of the equation of the hyperbola, which is quantity x plus 8 squared all over 36 minus y plus 1 squared all over 144 equals 1.
By having this standard form of the hyperbola, we can now get its center, which is at -8, -1, and the values of our a and b. Also, having a -y means that the hyperbola is horizontally oriented.
So now, let's visualize our graph. Our a sub h equals 6, then our 2a sub h, which is the length of our transverse axis, equals to 12. And then our b sub h equals to 12, which means that our 2b sub h, which is the length of our conjugate axis, is 24.
So, as for our ellipse, the center is also at -8, -1. Remember that in ellipses, the length of the major axis is always greater than the length of the minor axis. Thus, the transverse axis of our hyperbola is the minor axis of the ellipse, and the conjugate axis of our hyperbola is the major axis, where our a of ellipse and b of ellipse are equal to 12 and 6 respectively, which means we will have a vertically oriented ellipse.
By having the center, major, and minor axis of the ellipse, we can now have the standard equation of our ellipse, which is quantity y plus 1 squared all over 144 plus quantity x plus 8 squared over 36 is 1.
To summarize, first we wrote the standard equation of the given conic, then we identified the center and values of a and b. Thirdly, we identified the length of the transverse and conjugate axis. After that, we visualized our graph.
Following this, we determined the relationships of the hyperbolas, transverse and conjugate axis to the ellipse's minor and major axis. Lastly, we constructed the standard equation of the ellipse. And for the assessment of what you have learned, let's try these two. You can pause the video.
Time's up. Let's now check your answers.
You can pause the video.
Time's up. Let's now check your answers.
But aside from seeing these graphs in a Cartesian plane, we can also observe this in our surroundings.
One example of these are elliptical or circular roads.
Or have you seen a ring light in a certain angle that shows a reflection which has an hyperbolic shape? This is another real-life application of these combined conics.
And that's all for today. I hope that you guys learned something new about problems involving conic sections, specifically the relationship of an ellipse and a hyperbola. If you still want to test your knowledge and challenge yourself, you can try this.